Good morning, everyone. My name is Gagan Preet Kaur, and today the topic of in my series lecture, the topic of my lecture is assignment model in operation research. Now, before doing any example regarding assignment problem, what actually assignment problem is, we should get into that. In many business situations, like management need to assign jobs to the personnel, or we have to assign jobs to machine, or locations, salesmen to territories. These are only, we have only one person for a particular job or a location. So we have to assign in such a way that the cost incurred during that period is minimum. Like consider a situation like here of assigning n jobs to n machines. When job I is assigned to machine J, that incurs a cost Cj. For example, a salesman is assigned to a particular territory. That means he has to go over there. So a cost is involved in it. So we have to find a particular, you can say, scheduling of that person, so that the cost incurred is the minimum. So basically, like as I told you in simplex model and our PERT or CPM, that main objective of operation research is to have a minimum cost with maximum output. So the objective here is to assign the jobs to the machine at the least possible total cost or anything. Assignment model is a special case of transportation model. In transportation model, we have to assign, for example, like a mother dairy plant have to you can deliver milk products to all over India. So they have to assign particular plants or station to that region that will provide the you can say demand of that particular area, that can fulfill actually. So transportation is into that, where number of things are involved. But in assignment problem, there is only one source and one destination. The supply at each source is 1 unit and demand of at each destination is 1 unit. This is actually the, you can say, analytical view of considering your assignment model. Here the objective function is minimization, since we have to minimize the cost. So we have Cij, Xij, and for Xij, the, as I told you, source is 1, and for destination, destination is 1. One source, one destination. To continue with this assignment model, I will more elaborate this assignment model by taking an example. Let's take an example. For example, since it's an assignment model, it should be a square matrix. First thing is that assignment model should have a matrix which is square. That means if there are 5 rows, then it should have 5 columns. Eight, 16, 20. For example, this is job J1 and these are machine M1, M2, M3, M4, M5. The cost of operating job 1 on machine 1 is 11 rupees. The cost of operating job 1 on machine 2 is 17, and so on. This is 9, 7, 12, 6, 15. That is our job J2. Similarly, job J3, job J4, and job J5. In J3, it is 13, 16, 15, 12, 16. 13, 15, 16, 12, 16. These are the cost. which will be occurred while operating job on different machine. 21, 24, 17, 28, 26. 17, 28, 26. And the last row is 14, 10, 12 and 11, 13. Okay. Now we have a perfect square matrix over here. That means number of jobs is equal to the number of machines. In any case, if that happens, like machines are less, for example, there are only M1, M2, M3, M4 machines, then we have to add a column containing zero cost. That means M5 will be, all column will be of zero cost, similar and vice versa. Similar cases for rows. If our rows are less, then we will add a row over there which have a zero cost. So since it is a square matrix, we don't need to do that. Before doing this, there are some set of rules while doing all this method. Since it is a assignment method, it is done by Hungarian method. According to Hungarian method, first thing is you have to subtract the minimum element from each row, so that there is 1 0 in each row. Like here in this case, here the minimum element is 8. That means from each row minimum, subtract minimum number from each row. Now you can see like this. For example, here you can see 8 is the minimum element in row 1. So we will subtract 8 from this whole row, like 11 minus 8 is 3, 17 minus 8 is 9, 0, 8 and 12. Similarly, in this row, in the second row, the minimum element is 6. We will subtract 6 from whole row, that is 3, 1, 6, 0 and 9. Similarly, this here the minimum element is 12, 1, 3, 4, 0, 4, and in this case it is 17, 4, 7, 0 and 11 and 9. Similarly, in this case minimum element is, that is 10. This is 4, 0 and 2, 1 and 3. So this is, we have to create a minimum matrix actually. So since there is 0 in each and every row, the second thing is to have 0 in each column. Now we have to assess every column. We will see if there is any 0, or if there is not, then similar process will be followed. For example, in first column you can see that there is no 0. So what we will do, we will subtract the minimum element from each of this, and we will have a 0 in each column. For example, this is 1 minimum, so we will subtract 2, 2, 0, 3, 3. Similarly, here 0 is there, so we will write down, no need of subtracting the minimum. If we will subtract, nothing will be changed, because 0 is the minimum in column, and you will subtract from the whole column, then it will be same. So next one is, there is 0, there are in fact 2 zeros in this column, 8, 0, 0, 11, 1, and the last one there is no 0, and the minimum element in this column is 3. We will subtract it. 9 6 1 6 0. So this is our minimized matrix. Okay. After that starts the work of allocation. This is the our minimized matrix. Now we will allocate the jobs to the machine, and 0 is our minimum cost. If we will assign 9 or 8, that will not be feasible. We are basic objective is to minimize the total cost. So here first is 0. We will assign job J1 to M3 because it has a minimum cost. Now the zeros in this column will be, or on this side will be, crossed off, because you can't assign any other job to that machine then, because as I told you, source is 1 and destination is 1. So in second time it is, this is 0, that means J2 job is assigned to M4 machine, and the zeros over here will be cancelled. Okay. Next is our J3 job. This is 0. This is assigned to M1. Now there is no 0 in this row. So we have a marking method to do that. First we have to assign. Next is our, you can take any 0 and this one will be crossed. J4 has not been assigned, and so now we have to, that means there is further minimization is required in this matrix. We have assigned, it is okay, but still one job is left. We don't know which machine we have to assign it. So this is a big problem. So we have to minimize this matrix again. How we can do that? With the help of marking method. Just listen what I will be doing. Since this, first of all, mark the row which has no assigned 0. This is our row. This has been marked, which has no assigned 0. Second is, in that row where is 0, mark that column. This is marked. Okay. Now in this marked column, mark the row which has 0 in it. You can see this is the row column, and in this row the 0 occurs. Fine. Now again mark the column which has 0 in it. This is, since it is the last row, here 0 is there, but it is already marked. Now we will terminate it over here. What we will do next, in that means we have to cross the lines where minimization can take place. Here you have to cross the line. Just listen. Cross the line which column which has been already marked. This is the column, and cross the rows which have not been marked. That means we will cross these rows, these 3 rows. Okay. So it's a bit complicated. Now what we have to do? There are some uncovered elements in this whole thing. What we have done by marking, by crossing the column, after crossing the column and rows, there are some numbers which have not been covered with the line. So find out which is the minimum element which has been uncovered. According to this problem, 2 9 8 9 3 7 11 6. So these are the uncovered elements, and out of these uncovered elements, 2 is the minimum one. So we will do what? We will subtract 2 from every uncovered element, and we will add to the intersection points. Intersection points like this, this and this. Now I will make another matrix of this. Here J1, J2, J3, J4, J5, M1, M2, M3, M4, M5. Now let's go back. 2 is the minimum element, so it will be 0. Subtracting this, 0, 7, 0, 6, 7. 0, 7, 0, 6, 7, 2, 1, sorry, 2, 1. I told you here we have to add. This is the intersection point of these two lines. So 2, 1, 8, 0, 6. Next will be 0, 3. It is also intersection point. So it will be 6, 0, 1. Similarly, we have uncovered element 15094. 15094. Okay. So 15094. Next one is, this is intersection element 30410. 30410. So this is our new minimized matrix. So here we will do allocation again. We will see whether each and every job has been allocated to machine 1 or 2. So here we can see, like for example, here we take J1, this will be cancelled and this will be cancelled. J2, this will be cancelled. J3, still one job is left. That means further minimization is required. What we will do, we will mark this. This is our allocation matrix which has not any allocation. This is our matrix which has not any allocation. So these are, mark the row first of all which has no allocation. Mark the zeros in that, like these 0 have this column. Now in these row mark this row. Okay, here this row is marked. So further, like these row, there are 2 zeros and these zeros are in these column. In this row there is single 0, it's already marked. So here we can stop it since the loop has been made again. So next one is covering the elements. We have to cover column elements like this, and we have to cover the unmarked rows like this, like this. Okay. Now what we will be doing, 3 columns are been covered, and this. So what is the minimum element from these? 7, 1, 3, 5, 7, 1. 1 is the minimum element. What we have to do? We have to subtract from 1 from all the uncovered elements and have to add the 1 to the intersection point like this. These are the intersection points. Okay. So next minimization matrix will be created. Fine. Now we will minimize this matrix again. J1, J2, J3, J4, J5, M1, M2, M3, M4, M5. Now uncovered elements are, these are 6, 6, 0, 5, 2, 0 and 4, 3. Okay. Now intersection points are these 3. Here it will be 4, 5, 2, 0 and 0. Write down the remaining numbers which have nothing we have added or subtracted. That will be 0, 0, 6, 0, 6, 7, 2, 0, 8, 0, 0, 2, 6, 0, 1, 4, 0, 9. So this is the new minimized matrix which we have created with the help of marking rule. Now again we will assign the jobs to the machine like that. Here you can see this. I have assigned this here in this column, or in this it cannot be done like this. It has been assigned. Okay. Now this, fine, this and this. So you can see each job has been allocated to different machine. Like job 1 has been allocated to M1, job 2 has been allocated to M2, job 3 has been allocated to M4, job 4 has been allocated to M3, and job 5 has been allocated to M5. So here you can see now what are the original numbers which are on that zeros. We have to add them up, like it is 11 plus 7, that will give us the total cost. 11 plus 7 plus 12 plus 17 plus 13. The original number over these assigned zeros are as follows. So total cost will come out to be, that is around 60 rupees. So you can see how we have converted a simple matrix into assigning the job to the machines. Since it is a minimized cost which we will get in assignment, it helps us in decision making. Like we don't want to have a favorism or anything. We have a logic behind each and every decision of us. So what job will be assigned to which machine, or which the salesman can go to which territory. So these are all data based. So you can assign anyone, which keeping the view in mind that company has to incur the minimum cost. So here in this, with the help of this method, we have a minimum cost where job can be assigned to machine. I hope you have enjoyed this lecture. In case of any queries, you can contact me personally or mail me. My mail ID is kaur@akgec.ac.in. Thank you very much. Jai Hind.